Now we can also find the composition of the vapor phase. We can also find the composition in the vapor phase. So let us take this vessel. As I told you, there is a, suppose we have a solution in which we get to see a volatile solute. We did before also, volatile solute, as well as we need to see a volatile solvent also. So let us assume this small dots as solvents and these one as solute. So if the mole fraction of this solvent, so let us assume this as solvent, if the mole fraction of this is in the solution form is XA and in the vapor form let us say that it is Y1. And let us assume similarly that the mole fraction of solute be XB and in the vapor phase it is Y2. And we know that they are going to exert pressure. So let us say the pressure exerted is P1 and P2. And we also know that P1 is equal to P naught A into XA and P2 is equal to P naught B into XB. We know that. But you know that if we need to find the concentration in the vapor phase, that is the concentration of the solute in the vapor phase and concentration of solvent in the vapor phase, then how we are going to find that? The concentration of the, suppose let it be solute, this is A, right. So Y1, it calculated by the partial pressure of this 1A component divided by the total pressure. Likewise, if we need to find the composition of Y2, that is the solute concentration in vapor phase, we need to find the ratio for partial pressure for it when it is present alone divided by the total pressure. So this is how we can find our Y's in the vapor phase, that is the composition present in the vapor phase, right. Now, as we have seen that what is the vapor pressure when we have liquid solution and how it get affected. Now, it is a turn to explain that vapor pressure in which we are going to add a solid substance. So, now I am adding a solid substance to a liquid solution. So, that means my solute is solid and my solvent is liquid. As I told you that in both the cases we will be taking the liquid as solvent. So now what happens, suppose I have a container here, I have my solvent and as I told you solvent is volatile in nature. Likewise I have the solute particles, this is my solute, the red one. As I told you that the nature of this solid solute is non-volatile. So let us take an example where this our solid is non-volatile and this is volatile in nature. So now with passage of time what you get to see that there is a solvent particles present in a vapor phase. We will get to see that the solvent particles present in a vapor phase, but there will be no solute particle. As I told you, it is non-volatile, so obviously they are not going to get evaporated, but somehow they are going to decrease the vapor pressure of solution. They are going to decrease the total vapor pressure of the solution. The reason being because they will, like when the solvent is present in a pure form, the whole surface was covered by the solvent molecules and there were no hindrance offered to them and they can easily evaporate as much as they want, right. But now when we have solid solute, it will occupy a certain places at the surface, so it will just not allow the solvent particles which are present below to get evaporate. So somehow the vapor pressure of the solution will get decreased. So keep in mind or write in your copies that when you add a solid substance into a liquid solution, the vapor pressure of the solution just gets lowered. Now that means here we will be having a vapor pressure. Yes, we will be having a vapor pressure, but the vapor pressure will be strictly due to the total pressure will be strictly due to the pressure for the solvent, right. So that means it is equal to P naught, let us say solvent as A and solute as B. So it is XA, P naught A and similarly XB, P naught B. So this is not volatile as I told you. So let us say that the solvent is volatile. So obviously the total pressure is going to be equal to only the solvent, the partial pressure of the solvent into mole fraction of the solvent. Now this is what I just want to tell you that whenever there is a non-volatile solute, the total pressure is getting affected only due to this factor. That means because this is only volatile, that is not volatile in nature. So this is what you have to keep in mind.